Howdy, mindsetters. I'm back again. Yes, Looney. And now I'm with Peter.
Hi, Looney. How are you?
I'm good, thank you. How are you?
I'm not good.
What's wrong?
Oh, Looney, I'm really sad. Hey, Monday, we had a live show. Okay. And on our live show, it was 4 o'clock to 5 o'clock on Monday.
Yes.
I begged the viewers
Okay.
for them to let us know that I should have a new shirt. Because this shirt has shrunk. You can see it. It's got nothing to do with the fact that I put on weight. It's about 3 years old.
Okay.
And I said to the viewers that if 50 viewers say, yes, he needs another t-shirt, our producer was going to buy me one for the next show.
Oh, wow.
Do you know how many responded?
How many?
Not one. Not one.
No, that
So
means,
here
no,
I stand.
No, but it may be a compliment. You see what you see, maybe they see differently. They see you looking good. You see the shirt.
Look, you're very nice, but we both know this is not true.
It's not. It's very good. Nothing is wrong with that shirt. What are we doing for the mindsetters today?
All right, back to maths literacy, folk. So today what we're looking at is measurement, okay? And that involves us looking at conversion. It looks at area. It looks at volume. It looks at surface area. And although we're focusing on the grade 12, remember, if you're in grade 10 or 11, don't you dare go away, because we are looking at the paper 1 stuff today. And that, of course, comes into your grade 10 and your grade 11 work. So what we've decided to do is grab some questions from the 2012 paper 1 and the 2013 supplementary paper, the paper that was written in February and March, and we are going to take questions from that. Now remember, folk, because it's paper 1, we're expecting it to be a little bit easier than what we'd normally expect. This is a live show. At 5 o'clock, we're switching over to a pre-recording, which we did last week, and then we're going to look at shape and measurement again, but we're going to be looking at some paper 2 questions. So this is an introduction. We're looking at the basics. From 5 o'clock, we'll be looking at real hard stuff. But remember, from 5 o'clock, you can't ask us questions because it's not live. But now's the time to ask Looney as many questions as you can. So as I'm going through questions, if there's something you don't understand, say, whoa, write a note to Looney. She's going to tell you now exactly how to do it, and she'll let me know.
Well, mindsetters, trust me, from being here like all this time, I've never had a teacher who goes into so much depth just to tell you guys what we'll be doing. So please, Pete is such a dedicated teacher, guys. So make sure you are tuned in and you're having fun with us as we're here in studio going through that section. Remember to hit me up on Facebook, on facebook.com/LearnExtra. On Twitter, our handle is @LearnExtra. We do have a very great competition running for spring school. All you need to do is stop the clock. We're stopping the clock again, Pete, but it's very different this time around. So what you need to do, guys, is you need to tag or share the post that I will post on the Facebook page. Tag yourself or share it and write down your favorite number from 0 to 9. Okay, 0 to 9. When we stop the clock and we check our Facebook likes, when we stop the clock, it's the last digit of our Facebook likes. So if my favorite number is 2 and the clock stops on 2, and then maybe I stand a chance to win that hamper, I will win a special Learn Extra hamper, guys. So make sure you watch, because we will announce the winner, overall winner for today's competition close to the end of the show. So make sure you are tuned and you are watching us, because Pete is about to give you a great lesson, because he's such a great teacher, guys.
Oh, that's so sweet of you. Yeah, folks, don't forget to tag or to share, whatever that means. Okay, right, let's have a look at our first question today, adapted from November 2012, paper 1. Remember, we said we're looking at last year's past papers. Okay, here it is. Convert 23,005 liters to milliliters. Okay, now, if I'm a student in matric and I begin my exam paper, the first thing I'm going to write, okay, besides making sure my exam number's on the script and everything, I'm going to do the following. I'm going to say millimeters. Now, the first thing I can do is make sure I've got a pen that works. Okay, here we go. I'm going to say millimeters, centimeters, meters, and kilometers, right? Now, I know we're dealing with liters and milliliters. Let's just forget the question for now. Focus on what I'm doing. And I'm going to say, you know, the jump from millimeters to centimeters, centimeters to meters, and meters to kilometers. The first jump is 10. the next jump is 100, and the final jump is 1,000. What do I mean by these jumps? I'm meaning there's 10 millimeters in 1 centimeter. And guys, use your ruler in the exam, okay? Use it as a cheat tool. Now, you're not allowed to cheat in the exam, but you're allowed to take a ruler in, so use the thing. And you can actually look at your ruler and count how many millimeters there are in a centimeter, and you will discover that there are 10. You know a ruler or a meter is round about this length, okay? Normally from the tip of your finger to your shoulder is round about a meter. Unless you're a little kid and it's only this long, then of course it's not really a meter. But round about a meter from the tip of my finger to my shoulder here. Now if I were to put my ruler on my arm here, I would find I could easily fit 3 long rulers plus a little bit more, okay? In other words, there are 100 centimeters, because a ruler is 30 centimeters. So there's 100 centimeter in a meter. And there are 1,000 meters in a kilometer. Right. So how does this now relate to milliliters and liters? Well, if we were to work in milliliters and liters, instead of millimeters, we could say milliliters. We could then say liters and then say kiloliters. We don't normally deal with centiliters. Okay, so what's the jump from milli to liter? Well, we got a 10 and 100, so there's 1,000 jump. And from liters to kiloliters, there's another 1,000 jump. So when the question says this to us, how many milliliters are there in 23,005 liters? We know from milliliters to liters we've got 1,000 jump. Okay. Now by 1,000 jump, we're either talking about we're going to multiply by 1,000 or we're going to divide by 1,000. So how do we know which we're going to do? Well, guys, if I'm going this way, in other words, from kilometers to millimeters, I'm going to multiply. Why? Because there are more milliliters in 1 kilometer. Okay? There are a whack of millimeters. In fact, there are 1 million millimeters in a kilometer. If I'm going this way, I'm going to divide. Why? Because I have a whack of millimeters and only 1 kilometer. So if I'm going from millimeters to kilometers, I'm expecting less kilometers. Okay, so now let's go through this question quickly, and we're going to say, right, we have got 23,005 liters. We want to convert it to millimeters. We know the jump is 1,000, okay? And remember what we said, when we're going in this direction, from milliliters to liters, we're going to divide, okay? So let's go for it. We got liters, and in fact, we're going in this direction. We're going in the opposite direction, from liters to milliliters, so we're going to multiply. So I'm going to multiply that now by 1,000, and we're going to work out how many milliliters that's going to give me. Now, folks, I know that you know how to multiply by 1,000 or divide by 1,000 or whatever the case may be. However, my motto is always this. When you're writing your final exam, and if you matrics are listening to this, you will know that when you wrote your prelims, you were kind of nervous, okay? There was a little bit of nervousness in you, right? Looney, you wrote matric last year, didn't you?
I wish. No, a long time ago.
Long time ago.
Long time ago.
2 years ago.
3.
3. And you remember that when you did your prelims, you were nervous.
Very.
But when you wrote your finals?
It was more.
More nervous.
No, I was calmer but nervous at the same time because I knew what I was going to expect because I'd written my prelims, but it was still nerve-wracking because it's the final
right.
stage.
And because it's that final, the nerves are there. No matter how well you've prepared,
Yes.
you're still nervous. And because you're nervous, you make careless mistakes.
Yes.
Absolutely. So, instead of making careless mistake, my motto is use that calculator. And so that's what we're going to do. We're going to say we've got 23.005. We're going to multiply that now by 1,000 equals, and my calculator is going to give it to me 23,005 milliliters. Okay. Now I know you know how to do that, but folk, unless you've mastered that skill, there's no way you can get on to the more complicated questions that you'll find in paper 2. Right, let's move on. Time's moving on, and so we should as well. Here's a nice question. Again, it's adapted from November 2012 paper. So here we have a kind of weird and wonderful looking map. All right, not sure what it's about, so let's read the question. The question says, below is a street map of part of the area where Mr. Dahan lives. I think Dahan means chicken, doesn't it? So if it were, should be Mr. Chicken lives or something. But anyway, here's Mr. Dahan, and Mr. Dahan now lives in this area. Okay, we're not sure exactly where he lives. Now we are, because now we see here it says Mr. Dahan's house, and there's a little cross right there. What are our questions? In fact, before we even look at the questions, let's look at the map and get an overview of that map and see what's going on here. So if I look at that map, and I really hope it's coming out clear on your TV screen, I really do. Is it coming out clear on the TV screen? Okay, my producer's not talking to me today. All right. So here we go. So we've got his house over there. You'll see we've got different street names. All right. So we've got White Street, we've got Bryn Street, we've got Bird Street, George Street, Hill Street. We can see as well that we have a police station over here. We have a city hall complex. We have a nice sports stadium over there. We have a parking lot over there. All right. So I've got an overview of my map. Now that I have that overview, now I'm going to look at the actual question. Okay, and hopefully by having had an overview look at the map before even looking at the questions, when I do get to the question, I'm going to have a good understanding, and maybe I'll even know the answer before I've even read the question. Let's have a look. Question first one. Give the grid reference of Van Riebeek Sports Stadium. Now remember I said, hey, there's Van Riebeek Sports Stadium. Now what's the grid reference? Well, we know we're dealing in column C. This whole column here is column C. And in number 4, this whole row is 4. So the column and the row meet over here, which is C4. Okay? So that's my grid reference. Why do we have grid references, guys? We actually have grid references because in a huge, big, complicated map, and this one's not so complicated at all behind me, but normally in a complicated map, what happens is the examiner might say, find Elof Street. And you're thinking, jeez, where on earth's Elof Street? And there's just streets and highways and all kinds of weird and wonderful things on your map. But if he says, find Elof Street in block 4, or A4, you go straight to block A, row 4, column A rather, row 4, see where they meet, and then your search is limited to a specific block. That's why we use grid references. Right, my next question says this. Write down the names of the streets on either side of the City Hall complex. Okay, we said we've got a City Hall complex. Here it is over here. And now we need to find the names of the streets on either side. I'm going to take out a little rubber here and just clean up because I've made a huge mess and maybe we can't read anything on our map right now. Okay, there we go. Back to our pen and let's use yellow. So here's my City Hall complex. It's all in this area. The road above it is this road here, and this road is called Long Street. This road at the bottom of my city complex is called Marsh Street. So what are the two names on either side of the complex? Long Street and Marsh Street. This is easy, isn't it? Right, let's go on. Now, it says now Mr. Dahan drives out of the parking area of the Van Riebeek Sports Stadium and then turns right into George Street. So let's do this. And Looney, we're going to work together here, all right? Because you sit there all day, every day, doing absolutely nothing. Let's get you working. Right. So I want you to remember these instructions, all right? We're going to drive out of the parking area, okay, of the sports stadium and turn right. So let's do this. So here's the parking. We're coming out, And we're going to turn right.
George Street.
So we're going along this distance.
Yes.
Okay. Before I carry on now, I want to know what my next instruction is. So let's have a look at it. So my next instruction says this. He then turns left into Montague Street. Okay? And we're going to continue until we reach Marsh Street. Okay. So here we go. We're looking for Montague Street.
Turn left.
So here we go. We're driving along. Here's Montague Street. We turn left. And we're going to carry on until what happens?
Until you reach Marsh Street.
Until we reach Marsh Street. And there's Marsh Street.
There.
Now, my next instruction tells me this. In which direction must he turn? If he wants to go directly to the entrance of the police station. That sounds like trouble straight away. Okay. But he's going to the police station, so we've got to find that police station. Here's the police station. He wants to go directly to the police station. Okay?
Must turn right.
He's going to have to turn right. Absolutely. So he's going to turn right to get to the police station. Now, let's just have a look at this. It says in which direction, and we don't have a north and south here. Okay, so we're going to presume then the examiner wants us to say turn right. However, if we had this next to our map and the examiner said, what direction must I turn? I'm going to say, you know what, we're going to turn right in a easterly direction. Why easterly? Well, we know where north is. We know where south is. Okay, so we got north, south, and then we've got east and west, or west and east. And the way we remember it is we spell the word.
My teacher, I don't know the word, but my teacher always said never eat silkworms or now we shall eat.
It's all about food, eh?
Yep. So I don't know what word you created.
I just tell my guys, remember the word we.
Oh.
Okay, so we know where west is, we know where east is, but now you've brought food into it, which means it's time for an air break, because I think we've got to take some food quickly. All right, let's do this.
My sister, Pete and his little philosophies. So, we've got YOLO, right? You only live once. Pete has created a new one. Use that calculator, UTC. Remember that mindset is not YOLO, UTC. Use that calculator. And with that, we'll see you straight after this break. Welcome back, Mindsetters, from that very short break. I've shared a group on the Facebook page. Our Facebook page is facebook.com/learnextra. It's a Maths Lit group, Mindset Maths Lit. Please join it, guys, and then you can share it with other Mindsetters. Share all your knowledge about Maths Lit. All the bright sparks out there, help the other Mindsetters. If you guys need any help, we will post notes on there as well. So please join it, guys. Mindset Maths Lit. Mindset Maths Lit. That's the name of the group. I did share it on our Facebook page, so please go check it out. Join the group and go share your knowledge there. So all that said, Pete.
And don't forget our competition, folk, eh?
Yes.
The
Stop
number.
the clock, please.
Stop the clock.
I did post it on the Facebook page as well.
All right, cool. All right, folk, and to my horror, at the beginning of the show, I said, please, man, this purple shirt is an ugly color. It's not nice. It is small, it's shrinking. I've had it for 2 years. I need another one. But the producer will only give me another shirt if you folk out there, at least 50 of you say, give the man a new shirt. Please, I'm begging you. This is just getting so tight. I think the cold water washing detergent shrinking. Right. But enough of that. Let's get on with this show. So we're looking at a map, and we're looking at the area in which a certain guy lives. And his name is Mr. Dahan. Now, our next question, and I love this type of question. In fact, I'm very surprised it's in a paper one. It's probably one of the toughest paper one questions, but normally we see this kind of question in a paper two. And it's all to do with scale. And oh my giddy aunt, scale is one of the worst answered sections in matric. But I'm going to show you today a wonderful way of overcoming any problems to do with scale. Let's read the question. The distance measured on the map from Mr. Dahan's house to the entrance of Bayview Hospital is 8,9 seconds. So, the distance from Mr. DeHaan's house to the hospital entrance, now there's the hospital entrance, there's Mr. DeHaan's house, and we told the distance is 8,9 seconds. Now, folk, I'm not sure how they got that 8,9, so not seconds, 8,9 centimeters.
Wow.
I'm not sure how they actually got that distance, because obviously my map on my screen here and on your television is out of sync with the actual scale. So I'm not sure if the examiner measured the direct distance, or if he was saying, you know, the direction on the street is going to be 8,9 centimeters. But that's not the problem, okay? So let's have a look at it, and let's look at this. So what we're actually saying here is this, that we know the distance is 8,9 centimeters. Now, what is the actual distance in kilometers? If 1 centimeter on the map represents 0,3 kilometers. Right. Now, whenever you see the word scale, guys, the first thing that jumps into your mind has got to be map, real life. If you didn't know what figures belong to the map and what figures belong to real life, in other words, out there on the street, you can't go wrong with this question. So I'm going to say this, map, real life. And I get so annoyed with my students when they don't do this. In fact, I get very irritated. In fact, my grade 10s, if they don't do this, I take a mark off, because they've got to get into the habit of doing this. Okay, so we know that 1 centimeter on the map represents 0,3 kilometers in real life. But folk, we don't want to know how far 1 centimeter is. The question says, how far on the map, or how far in real life is 8,9 centimeters on the map? So instead of saying 1 centimeter, I'm going to say 8,9 centimeters. Now here's the question. How did I make that 1 become 8,9? I multiplied by 8,9. So we're taking this and we're saying times 8,9. Not times 8,9 centimeters, because we already got centimeters and centimeters. So I'm just multiplying by 8,9. And remember, whatever we do to the one side, we've got to do to the other side. Right? And I always use this, but let's use it again. So, Looney, do you have any brothers or sisters?
I have a sister.
You have a sister.
Yeah.
Younger, older?
Older.
All right. So she's the wise one, and then you came along. Okay. So now, Looney, how would you feel if your folks had called you together?
Yeah.
All right. And said, Looney, we want you to know, what's your sister's name?
Asamela.
Asamela.
Yes. Okay.
I thought you were going to say Tunes, because you're Looney, and she's
No,
Looney. Okay, Asamela. So she says to you now, or they say to you, Looney, we want you to know that we're giving Asamela an extra 100 Rand a week pocket money.
All right.
Okay?
Yeah.
And you get excited, don't you? Why are you getting excited?
Because she's getting extra.
She's getting extra, which means that
I get extra.
you're going to get extra,
Yes.
absolutely. So you wait in great anticipation. And so your folks say, so we're giving her an extra 100 Rand, and that's all we wanted you to know. You can go now.
Wow.
Okay, it would hurt, right? Why?
Because
you're sisters.
Yeah.
And what's good for the one
It's good
is
for the
good
other.
for the other. It's like Christmas. Imagine waking up on Christmas morning, okay?
Yeah.
And there's a phenomenal present for your sister. And your folks say, here's your Christmas. And she opens it and she's overjoyed because there's a, what is she like? A huge guitar and a wonderful musical instrument.
Okay.
And then you think, this is great. And they say, well, that's it for the year.
No,
okay?
that's not fair.
Absolutely. Because what happens for the one member of the family happens for the other. And folk, in the same way here, what we're doing on the one side, we're doing on the other. So if I multiply this side by 8,9, I'm going to multiply this side by 8,9. And I'm not going to do it, hey? What are we going to say?
Share.
Use the calculator.
Oh, yes. UTC. Use the
UTC.
calculator. Yes.
Use the calculator.
Yes.
Right. So we bring out this and we're going to UTC, and I've pushed all kinds of weird buttons down. The entire thing has just kind of disappeared. Here we go. All right, great. So we got something back. Okay, so what we're going to do is we're going to say we've got, and I'm going to shift my calculator this side. Where's it gone? Oh no, it's really going all over the place here. Let's try that again, shall we? Grade 12 maths, there we go. And we've got our calculator. Now I'm just going to shift our calculator so I can see what I'm doing. And I'm going to say 0.3 multiply by 8.9 equals, and my answer is 2,67. 2,67 what? Kilometers. Why? Because we said kilometers times 8,9. And we got 2,67 kilometers. So the distance on the map between Mr. Dahan's house and the hospital entrance, was it the hospital entrance? Yeah, it was, is measured by a ruler 8,9 centimeters. But in real life, if I got in my car and I drove that distance, I would be driving 2,67 kilometers. Okay? Important things, guys. Whenever we deal with scale, right? Map, real life. So we know all these figures here belong to map. And all these figures here belong to what's happening in real life or out there on the street. Okay, let's go on. We got another question. Let's read it up. Lungi made a rectangular. Is that name Lungi? Have I pronounced it correctly?
Lunja, yes. That's actually my niece's name.
Your niece's name?
Yes.
Okay. So, Lungi, if you're watching, how's it? This is all about you. Okay.
She's only 2.
So, she's only?
2.
All right, she won't be watching. She's only 2. Lungi made a rectangular box for his dog to sleep in. This helps to keep the puppy safe and comfortable. The dimensions of the box are as follows. The width is the same as the length of the dog, and the length is 125% of the length of the dog, and the height is 6 inches. Lungi's dog is 105 centimeters long. That's a weird way to measure a box, eh? Saying the width is the length of the dog, and the length is 125% of the dog, and the height now is in 6 inches, and we told as well that the length of the dog is 105 centimeters. So straight away, guys, in my mind, alarm bells are ringing. Why are they ringing? They are ringing because I'm dealing with both inches and centimeters. And guys, that is problematic. Okay? You cannot deal, whenever we deal with shape and measurement, we can never deal with millimeters and centimeters or kilometers and meters. We've got to get them to the same unit. In the same way, we can't deal with inches and centimeters. We've got to get them to the same unit when we work with it. But I think I'm jumping the gun. I think there's some easier questions before we even get there. Here it is. Give the following dimensions in centimeters. Now, what is the length of the box? Well, we know that the length of the box is 125%. Now, folk, when we see percent, what do? We know percent means 100. So we're going to go 125 over 100 times the length of the dog. And the dog is 105 centimeters. Okay, so how long is the box? And let's do this. Okay, so we take out our calculator. There we go, there's our calculator. And we're going to say now, we've got fraction button 125 over 100 multiplied by 105. And we get our answer, and our answer is 131,25. So 131,25 what? Centimeters. So that's the length of the box. So our dog's 106 centimeters. The box is 131,25 centimeters. Okay, now it says now calculate the height of the box. If 1 inch is 2,5 centimeters. So let's do this, guys. We're going to say 1 inch is equal to 2,5 centimeters. But we told that the height of the box is what? Is 6 inches. So we don't want 1 inch, we want 6 inches. How did I make the 1 become a 6? I multiplied by 6. Looney, what I do to one side?
You do to the other.
I do to the other. So times 6, we multiply this by 6. And our calculator is going to do that for us. So we're going to say we've got 2.5. Multiply that by 6 equals, and my answer is 15. So I've got equals 15 centimeters. Okay. So let's look at the dimensions of this box. We know that the length is what? 131.25 centimeters. The breadth of my box is the same as my dog, and my dog was 105 centimeters. So the breadth of the box is 105 centimeters. And the height of the box is going to be 15 centimeters. Okay? 15 centimeters. It must be a very, very small dog if that height is going to stop all the puppies from falling out. I don't quite understand that. Okay, but nevertheless, that's a tiny little squashed up dog. My wife has one of those things. You know, those little things that... They look like a rat more than a dog. Hey, to me, a dog's a dog. Like a German Shepherd or a Bull Mastiff, or not one of those little pokey...
Chihuahuas.
Chihuahua things, yeah. Okay, let's look at our next question, because I bet one of our questions is going to be, what is the volume of the box? Well, I hope it is anyway, otherwise I'm going to look like a ripe nana here. Okay, in fact, it's not. That was the end of the question. So I'm going back to this, and I'm going to say, what happens if they now asked us, what is the volume of the box? We would say the volume of the box is going to be length times breadth times height. The length of my box is 131.25 centimeters. The breadth of my box is 105 centimeters, and the height of my box is 15 centimeters. Now, folks, when we do that on the calculator, it's straightforward. We're going to say, I've got 131.5. I think I have. Let's check. Yeah, there it is. 0.25. Let's clear that. 0.25 multiplied by 105 multiplied by 15 equals, and I get this huge, weird, and wonderful fraction. 826.875 over 4. We push S to D, and we're going to get our answer, and there is our answer. 206,718, 206,718, comma, and it was, comma, 75. Comma, 75 what? Centimeters? No. Centimeters squared? No. Centimeters cubed. Why cubed? Because we're dealing with volume. If we ask for area, it would be centimeters squared. I think it's time for a break.
All right. Mindsetters, let's take a short break. Pete, we've got 2 people rooting for you to get a new shirt.
Only 2.
Aaron
48 more
and
you
Tato.
get on here now.
Thank
during
you,
break.
guys. Make sure you ask your other friends as well. Pete really wants to get a new shirt. Mindsetters will see you straight after this break. Welcome back, Mindsetters. So we've decided that we want to start a little campaign for Peter's shirt. Unfortunately, I don't know if I'm allowed to make a little page on Facebook, but we are rooting for him to get a new shirt. He doesn't want the color purple, so suggest colors that Peter's shirt should be. And please, guys, root for him to get a new shirt. We really want this to happen. 48 more people to go. He said he only needs 50 people to tell him that he needs a new shirt, and we will make sure that he gets a new shirt. Please, guys. Right now, we are going to stop the clock. So, Peter, do your thing there, just
right,
a young
so
refresh.
we're going to refresh the page, and
Yes.
I'll stop the clock on 8.
8, okay. So, Mindsetters, there you go. It's the end. We're done for today. Spring School competition for today is closed. 8 is the number. So, we'll collect all the numbers from all the live shows. Lucky draw will happen. I will tell you who the winner is before the end of today's show. So make sure you are still glued to your screens. even if you don't do my slit, make sure you watch and root for Peter to get a new shirt, and let's take the show on the road yet again.
Right, great. So let me get this. If anyone said 8 was their lucky number, those people's names get put in a hat.
In a lucky draw, as well as the other people from the other show, because we only have one winner from the 3 shows.
And what do we win?
A special learn extra hamper.
Do you know what's in the hamper?
No.
You don't? Sure, so it's a secret hamper.
Special, very special hamper.
Okay, cool. Well, if we get 50 things, I'll throw this in.
Of course.
There we go. All right.
Signed shirt and everything.
We could get into trouble for that. All right. Okay, now I've got to get rid of this screen because something happened here.
Just click on your lesson.
There we go. Ah, great. And we can get on with today's lesson. All right, so folk, we don't have very much time. In fact, we're down to 16 minutes and 13 seconds. In fact, now 11 seconds. So let's go. Question 4. Again, it's adapted from the November 2012 paper. Let's just find a color pen here. From the November 2012 paper 1. And remember what we said to you in the beginning of the show. All these questions are coming from a paper 1. Okay, so they're just touching on the fundamental or the important aspects of mathematical literacy. At the end of the show, at 5 o'clock, we're going to be putting on another show, but it's a pre-recorded show, so it's not me live, it's me not live. I don't know what you call it. Not shirt. Me dead, but me not live.
With a different shirt.
With a different shirt. Oh, with a different shirt. Okay, and what will happen there is we're going to be looking at questions on shape and measurement, but based on paper 2 type questions. Okay, let's go. The step at the front door of Maria's house is in the shape of a symmetrical trapezium base prism, as shown below. The step is made of concrete. The top, A, and the sides, B and C, will be tiled. Okay, so here's a step. And if I were to draw a house, and this could get scary, but let's draw it anyway. If I were to draw a house, and there's my wonderful house with the door, okay, believe it or not, that's the door. There's my little windows with the curtains in the background. Looks like a sad man. But anyway, there it is. What we've got here is we've got a step. And that's what this step actually looks like. And now they're going to give us a whole lot of dimensions with these steps. And I know the writing's rather small, but hopefully on your TV screen you can see it and it's a little bit bigger. If you can't, come closer to the screen. All right, so here we go. Now, we told this. The dimensions of the step are as follows. F is the length of the front of the step, 1,3 meters. So we know this is 1,3 meters. Guys, I'd advise you do what I'm doing. Put all the information on your diagram. It gives you a nice global picture of what's going on. Okay. S is the length of the slanting side, which is 1,6 meters. So we've got 1,6 meters over there. And I presume this is also 1,6 meters. Now, H is the height of the step. So our height of the step, there it is 0,12 meters. A is the area of the trapezium, and we told this area where A is, this whole area over here, okay, is 2,52 meters squared. We told the area of the slanting height of the step is B, so there's the area of that. And what shape is B? It's actually a rectangle, isn't it? It's just on the side of the step, but it's still a rectangle. Then we told C is the area of the front of the step, which we also know is a rectangle. Okay, and we're told that the top and the sides and the front are all going to be tiled. Now, the good thing about this question is this, that all my units are given to me in meters, every single one. And the area is given to me in meters squared. Now, that's probably one of the main differences between a paper 1 and a paper 2. If we were doing a paper 2, we'd probably give you some of them in centimeters, some in millimeters, some in meters, okay? And the area also in a different unit squared, which would really complicate things. But this is paper 1, so we expected them to be more or less the same unit, which they are. Now, concrete is made by adding water to a mixture of cement, sand, and stone in the ratio of Cement, sand, stone, 1 is to 2 is to 4. What's that mean? That means for 1 bit of cement, and what do I mean by bit? Well, it could be 1 spade of cement. If I use 1 spade of cement, I'm going to need 2 spades of sand and 4 spades of stone. If I use a bucket of cement, I'm going to need 2 buckets of sand and 4 buckets of stone. If I use a wheelbarrow, I'll use 1 wheelbarrow of cement, 2 wheelbarrows of sand, and 4 wheelbarrows of stone. Do you understand what this whole ratio thing's about? Of course you do. You've been doing it since grade 10, and you did it in grade 11, and now you're doing it again in grade 12. So now here's the question. How many wheelbarrows of stone will Maria need for 1 bag of cement if 1 bag of cement equals 1 wheelbarrow of cement? Okay, so let's read that again. How many wheelbarrows of stone will Maria need for 1 bag of cement? Okay, if 1 bag of cement equals 1 wheelbarrow of cement. So we told 1 bag is equal to 1 wheelbarrow. So in other words, I have 1 wheelbarrow of cement, I have 2 wheelbarrows of sand, and 4 wheelbarrows of stone. How many wheelbarrows of stone? The answer, quite simply, we're going to need 4. Okay, next question, here we go. The step at the front door of Maria's house is in the shape of this trapezium. Okay? We're now asking, calculate the volume of concrete in meters cubed required for the step. In other words, what we're saying, guys, is we have this like trapezium shape. How much cement are we pouring in there to fill it up? Now, the nice thing is our examiner has given us the formula. He's told us that the volume of the step is equal to the area of the trapezium times the height of the step. Okay? So what is the area of the trapezium? Remember we filled it in here. No, we filled it in our last one. But we were told it was 2,52 meters squared. So I'm going to say the volume is equal to 2,52 meters squared times the height. And we were told that the height of the step is 0,12 meters times 0,12 meters equals. So out comes the calculator. What do we say?
UTC. Use that calculator.
Use that calculator. Right. So that's what we're doing. UTC. Use that calculator. I'm going to shift the calculator over here so I can see everything. 2.52 multiplied by 0.12 equals, there's my answer, 0,3024. 0,3024. What? Meters cubed. Why meters cubed? Because we're dealing in volume. Now, guys, I've got a lot of decimal places. Okay? I've got 0,3024. Now I've got to ask myself, do I need to round this off? Okay. Now the question hasn't told me how to round it off, or has it? It said, yeah, calculate the volume of concrete in meters cubed, which I've done, required for the step. But it doesn't tell me how many decimal places. Now, folks, when you get a question like that in matric, and it doesn't tell you how many decimal places, you know you've got to round it to 2 decimal places. Why? Because when you look at the front cover of your exam script at the end of the year, it's going to say certain things like this paper consists of so many pages, it has so many questions, write neatly and legibly, you can use a calculator, and then it's going to say where necessary round to 2 decimal places. So if the question itself doesn't tell you how many decimal places, you know you've automatically got to use 2. Why? Because in the front of the paper, it might just say that use 2 decimal places. Well, that's what it said up to now. Okay, so chances are it could be the same at the end of this year. So I'm going to round that to 2 decimal places and say my answer is 0,30 meters cubed. There it is there. Okay, let's go on now. Hopefully Right. Are there any questions there while we're doing this?
No, but we have 6 people now who are rooting for you to get a new t-shirt.
Only 6 people. In fact, we've got like 5 minutes of the show left. And we've only got 6 people saying I must get a new shirt.
No,
we
but
need 50. I need
we'll
another
get
44.
more.
So you just get there quickly. You've got
Yes,
5 minutes.
yes.
What colors are they saying?
White.
White.
Yes.
I like it. Right, let's go on. Maria wants to tile the top and the side surfaces of the step. Calculated, rounded to 1 decimal place. Now, folk, remember I just said to you, if the question doesn't tell you, you know you've got to round it to 2. Here the question's saying, oi, round to 1 decimal place. So I know that's what I'm going to do. And we've got to calculate the total area that's going to be tiled. And the total area of the step must equal that top area, okay? And what was that top area? Do you remember what it was? It was 2,52 centimeters. So we're going to say 2,52, not centimeters rather, meters squared, plus 2 times S. What was S? S was the length of the slanting side, which was 1,6 meters, times 1,6 meters plus F. What was F? F was the length of the front of the step, which was 1,3 meters. So plus 1,3 meters. Okay? Close bracket, multiply that now by my height. And what was the height again? Our height was 0,12 meters. So times 0,12 meters. Sure. This is where it's a phenomenal thing that we actually have a calculator. So when I see a sum like this, what am I going to say?
UTC, use that calculator.
Use that calculator. Right, so out it comes. And our calculator is going to say 2.52 plus, open the bracket, okay, 2 times 1.6. Now I'm going to shift my calculator to this side so I can see the rest of the question. Plus 1.3. Close the brackets. Times 0.12 equals, and there's my answer, 3,06. Now, folk, 3,06 what? 3,06 meters squared. Why squared? Because we're calculating it in area. And our examiner was quite nice as well. Hey, he said, hey, your unit must be in meters squared. Now, let's just check if we've answered this question correctly, because I can see a mistake already. Because the question said, remember we circled it, round off to 1 decimal place. So let's check it here. 1 decimal place is going to be 3, that's a big number, 3,1 meters squared. Okay. Now, I always tell my students this, that when they finished a question, there's a few things they've got to ask themselves. Number 1, have I answered the question? Now, that sounds like a silly thing to ask yourself, okay? But it's so true. Especially like, let me give you an example. For example, you're calculating interest, okay? And the question says how much interest was earned. But you calculate the whole amount, including the interest. And you're so chuffed with yourself, you're so pleased with yourself that you stop there. But that wasn't the question. The question was, calculate the interest, not the whole amount with the interest. Okay, do you understand what I'm getting at? So number 1, have I answered the question correctly? Number 2, does my answer make any sense? So I once saw a maths question where a group of students had to calculate the diameter or the length, okay, of an elephant's brain, right? And one student got 142 or something ridiculous like that. It was close on 150 kilometers. Now, folk, if you've got an elephant with a brain 150 kilometers long, right? That's like saying from Joburg here, way past Pretoria. If you've got an elephant that's got a brain that size, I want to tell you now, let's all just drop everything and run and don't stop running. Okay? So surely that student must have looked at that question and says, you know what, this doesn't make sense. I can't have an elephant with a brain 150 meters long or 150 kilometers long. That's not possible. So, number one, have I answered the question? Number two, does my question or does my answer make any sense? And then number three, have I rounded correctly? And Lenny, maybe you can come up with a funny saying with that, okay? So it's correct question.
Yes.
Correct answer, rather. Oh, yeah. Have I, does it make sense? And have I rounded correctly? Okay, so you think about that one. In fact, you can't think very much because you're going to have to do some talking now.
Yeah,
Guys.
mindsetters can send it out to the mindsetters. They can think of one.
Okay,
Yes.
excellent. All right, folk. Time's gone. We've got about a minute left, and I know Looney's got to announce winners and do weird and wonderful things like this and sign off. Thanks so much for joining us today. I really appreciate it. Remember, after the show at 5 o'clock, we have another show. It's not live, though, but it's looking at shape and measurement, looking at paper 2 questions. So it really tests the brain. That's it from me, folks. Thanks for signing in, and we'll chat later. Enjoy the rest of your holiday.
Thank you so much, Pete. Guys, I did post a little campaign for Pete on our Facebook page. Go check it out, like it. If you get 50 likes and suggestions, he will get a t-shirt. Congratulations to Mwaku Offense Muasa. You have won yourself that very special Learn Extra hamper. So congratulations to you. You will be contacted and we'll get all your details. Thank you so much, Mindsetters, for tuning in. Remember, pre-record after this. I will see you tomorrow. Until then, goodbye.
And there are 1,000 meters in a kilometer. Right. So how does this now relate to milliliters and liters? Well, if we were to work in milliliters and liters, instead of millimeters, we could say milliliters. We could then say liters and then say kiloliters. We don't normally deal with centiliters. Okay, so what's the jump from milli to liter? Well, we got a 10 and 100, so there's 1,000 jump. And from liters to kiloliters, there's another 1,000 jump. So when the question says this to us, how many milliliters are there in 23,005 liters? We know from milliliters to liters, we've got 1,000 jump. Okay. Now, by 1,000 jump, we're either talking about we're going to multiply by 1,000 or we're going to divide by 1,000. So how do we know which we're going to do? Well, guys, if I'm going this way, in other words, from kilometers to millimeters, I'm going to multiply. Why? Because there are more milliliters in 1 kilometer. Okay? There are a whack of millimeters. In fact, there are 1 million millimeters in a kilometer. If I'm going this way, I'm going to divide. Why? Because I have a whack of millimeters and only 1 kilometer. So if I'm going from millimeters to kilometers, I'm expecting less kilometers. Okay, so now let's go through this question quickly. And we're going to say, right, we have got 23,005 liters. We want to convert it to millimeters. We know the jump is 1,000, okay? And remember what we said, when we're going in this direction, from...
Howdy, Mindsetters. I'm back again. Yes, Looney. And now I'm with Peter.
Hi, Looney. How are you?
I'm good, thank you. How are you?
I'm not good.
What's wrong?
Oh, Looney, I'm really sad. Hey, Monday, we had a live show. Okay. And on our live show, it was 4 o'clock to 5 o'clock on Monday.
Yes.
I begged the viewers
Okay.
for them to let us know that I should have a new shirt. Because this shirt has shrunk. You can see it. It's got nothing to do with the fact that I put on weight. It's about 3 years old.
Okay.
And I said to the viewers that if 50 viewers say, yes, he needs another T-shirt, our producer was going to buy me one for the next show.
Oh, wow.
You know how many responded?
How many?
Not one. Not one.
No, that
so
means,
here
no,
I stand.
No, but it may be a compliment. You see what you see, maybe they see differently. They see you looking good. You see this shirt.
Look, you're very nice, but we both know this is not true.
It's not. It's very good. Nothing is wrong with that shirt. What are we doing for the mind teachers today?
All right, back to maths literacy, folk. So today what we're looking at is measurement, okay? And that involves us looking at conversion. It looks at area. It looks at volume. It looks at surface area. And although we're focusing on the grade 12, remember if you're in grade 10 or 11, don't you dare go away, because we are looking at the paper 1 stuff today. And that, of course, comes into your grade 10 and your grade 11 work. So what we've decided to do is grab some questions from the 2012 paper 1 and the 2013 supplementary paper, the paper that was written in February and March, and we are going to take questions from that. Now remember, folk, because it's paper 1, we're expecting it to be a little bit easier than what we'd normally expect. This is a live show. At 5 o'clock, we're switching over to a 1. Remember we said we're looking at last year's past papers. Okay, here it is. Convert 23,005 liters to milliliters. Okay, now, if I'm a student in matric and I begin my exam paper, the first thing I'm going to write, okay, besides making sure my exam number's on the script and everything, I'm going to do the following. I'm going to say millimeters. Now, the first thing I'm going to do is make sure I've got a pen that works. Okay, here we go. I'm going to say millimeters, centimeters, meters, and kilometers. Right? Now, I know we're dealing with liters and milliliters. Let's just forget the question for now. Focus on what I'm doing. And I'm going to say, you know, the jump from millimeters to centimeters, centimeters to meters, and meters to kilometers. The first jump is 10, the next jump is 100, and the final jump is 1,000. What do I mean by these jumps? I'm meaning there's 10 millimeters in 1 centimeter. And guys, use your ruler in the exam. Okay? Use it as a cheat tool. Now, you're not allowed to cheat in the exam, but you're allowed to take a ruler in, so use the thing. And you can actually look at your ruler and count how many millimeters there are in a centimeter, and you will discover that there are 10. You know a ruler or a meter is round about this length. Okay? Normally from the tip of your finger to your shoulder is round about a meter. Unless you're a little kid and it's only this long, then of course it's not really a meter. But round about a meter from the tip of my finger to my shoulder here. Now if I were to put my ruler on my arm here, I would find I could easily fit 3 long rulers plus a little bit more. Okay? In other words, there are 100 centimeters, because a ruler is 30 centimeters. So there's 100 centimeter in a meter. Pre-recording, which we did last week, and then we're going to look at shape and measurement again, but we're going to be looking at some paper 2 questions. So this is an introduction. We're looking at the basics. From 5 o'clock, we'll be looking at real hard stuff. But remember, from 5 o'clock, you can't ask us questions because it's not live. But now's the time to ask Looney as many questions as you can. So as I'm going through questions, if there's something you don't understand, say, whoa, write a note to Looney. She's going to tell you now exactly how to do it, and she'll let me know.
Well, mindset is, trust me, from being here like all this time, I've never had a teacher who goes into so much depth just to tell you guys what you'll be doing. So please, Pete is such a dedicated teacher, guys. So make sure you are tuned in and you're having fun with us as we're here in studio going through that section. Remember to hit me up on Facebook, on facebook.com/LearnExtra. On Twitter, our handle is @LearnExtra. We do have a very great competition running for spring school. All you need to do is stop the clock. We're stopping the clock again, Pete, but it's very different this time around. So what you need to do, guys, is you need to tag or share the post that I will post on the Facebook page. Tag yourself or share it and write down your favorite number from 0 to 9. Okay, 0 to 9. When we stop the clock and we check our Facebook likes, when we stop the clock, it's the last digit of our Facebook likes. So if my favorite number is 2 and the clock stops on 2 and then maybe I stand a chance to win that hamper, I will win a special learn extra hamper, guys. So make sure you watch, because we will announce the overall winner for today's competition close to the end of the show. So make sure you are tuned and you are watching us, because Pete is about to give you a great lesson, because he's such a great teacher, guys.
Oh, that's so sweet of you. Yeah, folks, don't forget to tag or to share, whatever that means. Okay, right, let's have a look at our first question today, adapted from November 2012 paper, milliliters to liters. We're going to divide, okay? So let's go for it. We got liters, and in fact, we're going in this direction. We're going in the opposite direction, from liters to milliliters, so we're going to multiply. So I'm going to multiply that now by 1,000. And we're going to work out how many milliliters that's going to give me. Now, folks, I know that you know how to multiply by 1,000 or divide by 1,000 or whatever the case may be. However, my motto is always this. When you're writing your final exam, and if you matrics are listening to this, you will know that when you wrote your prelims, you were kind of nervous, okay? There was a little bit of nervousness in you. Right. Looney, you wrote matric last year, didn't you?
I wish. No, a long time ago.
Long time ago.
Long time ago.
2 years ago.
3.
And you remember that when you did your prelims, you were nervous.
Very.
But when you wrote your finals?
It was more.
More nervous.
No, I was calmer but nervous at the same time, because I knew what I was going to expect, because I'd written my prelims, but it was still nerve-wracking because it's the final
right.
stage.
And because it's that final, the nerves are there. No matter how well you've prepared,
Yes.
you're still nervous. And because you're nervous, you make careless mistakes.
Yes.
Absolutely. So instead of making careless mistake, my motto is use that calculator. And so that's what we're going to do. We're going to say we've got 23.005. We're going to multiply that now by 1,000 equals, and my calculator is going to give it to me 23,005 milliliters. Okay. Now I know you know how to do that, but folk, unless you've mastered that skill, there's no way you can get on to the more complicated questions that you'll find in paper 2. Like